Now, we're going to switch to geometric proof, but not a very big switch yet. Uh, we are going to use algebra for these geometric proofs. And the way we use it is we use what we know about geometry to set up some sort of equation, and then we use algebra uh, to get to the result that we're looking for. Um, so if two angles are equal, we find out what expressions represent those angles, and we set them equal to each other. We have some rules that are similar to the properties of equality. These ones are referring to segments and angles, and the main idea is we can add in the reflexive, symmetric, and transitive properties, and those work just as well. Now, reflexive, everything is equal to itself. Symmetric, you're allowed to change which side that they're on. The transitive is the only one that's a little bit different, but the main idea is if you have, and I'm going to do it with algebra instead of with segments or angles here, slightly less symbols. If you say x is equal to y, and then you know that y is equal to 2, just like we were talking about before with conditional statements, since we have y on the right and y on the left here, we can bypass it and just get straight to x equals 2. That's the way that the transitive property works for segments and for angles. So, example 3. We're going to write a geometric proof. If angle FGJ is congruent to angle JGK, and angle JGK is congruent to angle KGH, then x equals 6. Now, we're going to always start off with what we are given, and our conjecture is x equals 6. We have to get down there somehow. So when we start out, you notice we're just given the expressions of angles. So we know we have to change those angles from the generic names to their expressions at some point. And then we have to maybe solve some sort of equation. Now, let's set up our columns here. So there's my vertical column, and we will do a horizontal column. Statements, reasons. All right, what are we given? Angle FGJ is congruent to angle JGK, and angle JGK is congruent to angle KGH. These are both given. Now, before we switch to any sort of algebra, what I'd like to do is there any sort of relationship that I can use to simplify the geometry that I know? And if you take a close look here, JGK exists in both of these congruence relationships. And since they do, and one's at the end and one's at the beginning, we can use that transitive property of angles. So, transitive property of angles. I get to skip over the angle JGK. FGJ is congruent to angle KGH, and that is the transitive property. Up next, do we have any sort of algebraic expressions for any of these angles? And I'm going to highlight FGJ in red there, and you can see we have an expression. That is something that's given to me because it's in the picture for the problem. So I'm going to say the measure of angle FGJ equals 6x plus 7, And then I'm also going to say, I'll do it in green here, KGH is measure of angle KGH equals 8x minus 5. These are also both given. This time the givens are not from the description in the problem, they're given from the image. But we don't need to tell us where where they came from. We don't have to say given in image or given in figure or anything like that. We just say it's given. Because you can read it, it's right there. Now, the next idea is how do we convert congruence into equality? Well, if two angles are congruent, then they have the same measure. So the measure of angle FGJ is equal to the measure of angle KGH. This is the definition of congruence. And it seems kind of odd that I've done that a little bit separately, but the way I was kind of organizing is, what do I know about geometry? Okay, I made a conclusion. Do they give? I got to switch it to algebra at some point. Do I know anything about that? Oh, I know these two expressions. Oh, another thing, I also know this relationship now. And notice I was very careful about making sure I put the measure of the angles there, because my angles, FGJ, I know what it equals in an expression. 6x plus 7. And I know what the measure of KGH is. I have it in an expression. 8x minus 5. Now, those things I highlighted there were just changing how the value is expressed. So we used the justification substitution. Now, this is kind of a longer one, but it's our first real geometry proof. Next up, what do we have to do? Well, we just have to keep solving the equation, right? Now it's all just back down to algebra, so we just keep doing algebra on it. I'm going to subtract 6x from both sides, and I get 7 equals 2x minus 5. We'll call this the subtraction property. Subtraction property of equality. Let's add 5 to both sides, so I get 12 equals 2x, and that is the addition property of equality. Divide both sides by 2, and we get 6 equals x. That is the division property of equality. And I'm not writing the steps here for solving the algebra, but if you want to, on your little notes as you're working through the problem there, put in what you're doing. Oops, plus 5 to both sides. Divide by 2 on both sides. You're welcome to do that if that helps you keep track of it. Now I have 6 equals x, but our actual claim was that x equals 6. So I have to flip it. So the very last step is just flipping it, x equals 6, and that is the reflexive, that's the symmetric property. Symmetric property of equality. And I close off my proof. And that is your first full-on geometry formal proof.